So because of that, I'm going to get started right away. And the first thing I want to do is ask you all, who is in Bluesky? Are you all in Bluesky? Do you know Bluesky? Raise your hands if you know Bluesky. You know what it is? Okay, just a few people. Let me just show you what Bluesky is very briefly then. But Bluesky is a social network, very similar to Twitter. So you can have posts, they're very similar to tweets. But the difference between Bluesky and other social networks, most of them, is that's a decentralized network, meaning that there's not a single entity behind Bluesky. So it works, roughly speaking, like email. So if you're not happy with the provider you're using to communicate with the whole social network, you can always change to a different provider and take with you your account with your followings, your followers, your posts, your blogs, everything to a different provider, or even host one yourself. So it's a pretty cool and technological network. It's pretty interesting. You should all check out the protocol behind that. But another cool thing about Bluesky is that they offer a WebSocket that they call Jetstream or Firehose that you can listen to and see everything that is happening in the social network in real time. Posts being created, people following each other, people blocking each other because blocks are public in Bluesky as well. Accounts being created, you can see everything in real time, all right? But what I'm interested in is actually the posts that are being created in real time for the application we're going to be building together today. Okay, and now I want to ask you, how many posts are created in Bluesky per minute? I don't want you to answer, I'm going to help you with that, because it's approximately 2,200. Right? It's not a lot, if you think about it, like a minute, 2,200, it's not substantial. But if you think about a month, for example, we're talking about 9.5 million posts per month today. And today they have 36 million users in Bluesky. By the time I joined in August of the last year, there were only 10 million. So we don't know if it's going to be 9.5 million per month next month as well. It might increase as the number of posts increase as well. So how can we efficiently analyze all of this data, right? It's a lot of data. How can we do that? And here is when you come to what we're actually be building today. So basically, we're going to be building an application that is going to listen to Bluesky's Jetstream. It's going to filter posts that are related to artificial intelligence. We're going to enrich the data from these posts by extracting topics from it, implied topics that we don't know about. And then we want to keep track of the frequency of these topics as well, so we can do further processing later on, or analysis. And finally, we want to allow Bluesky users to interact with their bot and ask questions by the end of the presentation. All right? And how are we going to do that? By leveraging some stuff, such as Redis streams, semantic classification, which is a technique using vector similarity search, semantic routing, which is also a technique using vector similarity search, semantic caching, that it's also a technique using vector similarity search. And finally, if we have time by the end of the presentation, I'm going to dive a little bit superficially in probabilistic data structures, which are great for huge data streams like the one that we're going to be consuming from Bluesky today. So it takes us to the first challenge, challenge number 1, storing the messages. And, oops. Why we want to store the messages? Because the messages that come from the WebSocket are ephemeral, right? If you don't listen to them, if you don't consume them, if your application is not running, you're not going to be able to consume them later. So you're going to store them somewhere so you can do further process later on. And also because we're going to consume these messages from multiple services, and I want the services to consume the same messages. I don't want one service to consume message A and service B not consuming message A afterwards because it wasn't down at the time that it happened, all right? So that's why we're going to store the messages. And how are we going to do that? By using Redis streams. So Redis streams is actually a data structure that was added to Redis back in 2017. Did you know that Redis had streams? Nobody knew. Oh, one hand there. Yeah. Did you know Redis? Do you know Redis? Everybody. Yeah, it's quite popular, right? Did you know Redis is more than a cache? Nobody. That's just a few hands. Yeah, exactly. See, Redis is more than a cache. It has evolved in the past 15 years. It has a lot of different data structures, a lot of use cases, a lot of capabilities. It's a very cool database. I'm very passionate about it. Okay, but going back to Redis streams, this is the take from Redis for streams of events, all right? First of all, they're super fast because they're in memory first. So basically, whatever client that is ingesting or consuming from this stream is going to do that from the memory. But it doesn't mean that this is not persistent. Redis, in a sub-process, might persist that to the disk if you want to. So it can be persistent as well. But since it's going to be read and consumed and written to the memory first, it's super fast. They're easy to set up, so no brokers, no zookeepers, none of that. You only need a Redis instance. Docker run Redis, that's all you need, and you can have Redis streams, all right? Great. They also support consumer groups, so basically you can have multiple replicas of the same application listening to the same consumer group from the same stream and consuming different messages. So you can have all these replicas from the same application tackling the same stream and, well, consuming these messages faster than they would if there was only one replica of this application, right? And finally, it's a perfect fit for real-time pipelines. This is a beautiful diagram that I came up with explaining what we're going to do. So basically, you're going to get the messages from Bluesky and insert them into a Redis stream using the WebSocket. All right? So that, as I explained to you before, we can have multiple applications listening to the same stream, consuming events from that at the same time, at their own time pace as well. All right? And here you can see that it can have multiple consumers, so basically multiple replicas of the same application listening to the same consumer group, listening to the different messages from this stream, so that you can tackle that faster. So those are just some diagrams. Let's go to the code. Show me the code. I love the code. OK. Jetstream. This is the first notebook I'm going to be showing you. Let me include some dependencies. Oh, you know, when you share the screen, everything gets so small in my own screen. And you can see that my glasses are very thick. I cannot see, so I get very close. So I have this function here, the consume string. And this function is going to receive a limit, so basically the number of messages we want to consume at a time for demo purposes. And it's also going to receive a higher order function, which is the onEvent function here, okay, which we're actually going to invoke for each message that we consume from the string. So this is the URL of the WebSocket. We're going to be using Ktor here to consume this WebSocket. And then for each of the messages, we're going to invoke the function that is passed. All right, so let me create this function. And let's test it out. Let's try to run that with 5 messages. And it didn't work. Why? What happened? Let me restart the kernel. See, we have the demo, and you have the troubleshooting demo. This might be the troubleshooting demo today. Let's see. OK, now it's going to work. No. I'm not connected to the internet. Oh, no, Kotlin Conf. Oh, I can't believe such a beginner's mistake. Maybe because I'm a beginner. Let's try it again. OK, so you can see that we consume the messages in real time. 5 messages consumed from the Jetstream WebSocket. And every time you run it, we get 5 different messages. OK, so now let's insert these messages into Redis stream. So what I want to do is include this dependency, which is the Jetties, which is the client library for Java, which naturally works very well with Kotlin as well. I'm going to create a pool of connections with Redis. And what was that? That is an extension function that is going to turn the model, the data class that I created from the messages into a hash that is going to be stored, or a map, in other words, that is going to be stored inside of the stream. And finally, I'm going to have this function that is the add to stream function that is going to add the map into, or the hash, in other words, into the stream, calling the xadd command from Redis. All right, and let's try it out. Let's try to add 4,000 messages into Redis. Let's see if it works. Is this big enough? Oh, yeah, it's quite big. I hadn't seen this. Wow. Good for people who wear glasses like me. OK, so if you go to this application now, which is called Redis Insight, which is the graphical user interface developed by Redis, so people can interact with the database in a very friendly way. If you come here right now, you can see, and let me zoom in a little bit, that you have the stream. So the Jetstream stream was created, and all of these messages were inserted into it already. And you can see that we have 1,719 messages inserted into it. And every time you refresh, you can see that they're still being inserted, actually, because it's going to take around 2 minutes to insert 4,000. If you remember, approximately 2,200 per minute, right? So while it's loading, let's go back to the presentation. But, sorry, I also wanted to show you that all of these messages, they have a text as well. So you can see the text, you can see the language, you can see the ID of the user who posted the message, and so on. A lot of information here for us to analyze later on. Let's go back to the presentation now, because that's how we tackled the first challenge. Now let's talk about the second challenge, which is filtering the messages, all right? And filtering the messages can be done using LLMs or vector databases, all right? But why do we want to filter the messages? Because, as I told you in the beginning of the presentation, I want my bot to analyze messages about artificial intelligence, right? So that's what I want to do. And here we had the diagram of the first challenge. And now what I want to do is consume the messages that were created into this Redis stream from another service, which is going to be the filtering service. And for every message that is actually about AI, I want to insert it into a different stream here, which is going to be the filtered Bluesky post stream that then can be consumed by other applications that are only interested in the filtered messages by themselves. All right, let's zoom in on what happens inside of the filtering service, because we're going to talk about two ways of doing that. The first one is the way that most people are doing today, that is using an LLM. So basically what they're doing, they're getting the post, they're going to the LLM and saying, hey, is this post about artificial intelligence? And if it is, they continue with whatever they're doing. In our case, we're going to insert that into a string, and you're also going to store that in Redis as a hash or as a JSON. Right, but what's the problem with this approach? The problem is that it can become expensive very easily, all right? So if you call LLMs for everything, by the end of the month, you can see that, well, maybe your bill is going to be very high as well. And it's also time-consuming because LLMs are not really instantaneous, right? They take like a second, sometimes 2 seconds to reply, depending on the LLM you're using. And it takes us to the second approach, which is basically using a vector database, which is Redis in this case, all right? And if we use a vector database to do so, you can do that by actually first going to an LLM, only one time, okay? You can do that yourself. You go there and you ask it, hey, can you generate 500 Bluesky posts about artificial intelligence, for example? So you ask it to generate synthetic data for you, so that you're faster. You can also generate this data yourself if you want to be more accurate, all right? Then what you're going to do is use an embedding model to turn these posts into meaningful numerical representations, which we call vectors. And then you're going to store all these vectors into Redis, which is our vector database today. But before we continue, I want to ask you, do you know what an embedding model is? Raise your hands. Just a few hands? Okay, most hands. That's good. But just a quick recap, an embedding model is basically a machine learning algorithm specialized into turning unstructured data, such as text or images or audio, into meaningful numerical representations, all right? So that you can compare these vectors somewhere later on and check how similar they are. So let's say that you come up with a sentence that is, I want to have breakfast, I want to have coffee for breakfast, and he comes with a sentence that is, I want to have café for breakfast. How can you see mathematically how similar these two sentences are semantically, right? You turn them into vectors, and then you then compare the vectors. And if the vectors are similar enough, it also means that the sentences are similar semantically. So that's an embedding model in a nutshell. And that's what we're doing here. After we have stored all of these vectors into Redis, what we want to do is having our filtering service consuming the events from the stream, getting each post, vectorizing this post as well, then going to the database and saying, hey, is this vector similar to any of the vectors that I added to the database before? And if it's similar enough, it means that they're actually about the same thing. They're also about artificial intelligence. And if they're about artificial intelligence, then we can continue the processing. So you see, we don't have to go to the LLM. You can just use a vector database and a fast one that is Redis today. Right, let's look at the demo. And I'm sorry, the stopwatch is not working here. I'm not sure how, if you can fix that, because I don't know how much time I have. So this is the second notebook. So let me zoom in, and I have the coroutines here. I'm going to include this into my notebook. Then I'm going to create this function that is the create consumer group to read from the string. This is going to receive the stream name and the name of the consumer group. And we also want to consume from the first message that has ever been generated. All right? Then I'm going to have the create consumer group function being called for this stream, which is the jet stream, with this name, which is the printer example. And after that, I can already show you, actually. I can come back to Redis Insight and show you this tab, which is the consumer groups. And you can see that this consumer group was created. It has 0 consumers so far, and it has never consumed any message, all right? What I want to do now is create this function that is the read from string, which receives a string name, a consumer group, the consumer itself, and the number of messages we want to consume at a time from Redis. All right? And then I want to create an acknowledging function so that I know that this event has been consumed successfully, and I can tell Redis, hey, you don't have to deliver this message ever again to the same consumer group. And finally, I'm going to create this function that is going to orchestrate all of that together, right? So basically, this is going to be the consume string function. It's going to receive the information from the consumer. It's going to receive a list of higher order functions, which are actually the functions that are going to be called for each of the messages that I consume from the string. And it is also going to receive the acknowledging function, all right? And finally, we're going to have the count, which is basically how many messages we want to consume from Redis at a time. And also the limit, which is, for demoing purposes, the number of messages we want to consume in total when you call this function. And what I want you to pay attention from this algorithm here is that it's going to read from the string. It's going to store the entries here. And basically, for each of the events, what we're going to do is we're going to go through this list of functions, and we're going to invoke each one of them for the message, all right? And if all of them succeed, then that's fine. If any of them fail, then the subsequent ones are not going to be run. Okay, so that's how I implemented that. So the first function I'm going to create is the print URI function. It's a lambda, actually, that I stored in this variable print URI. And I'm going to call the consume string function with the information from my consumer, which is going to be printer1 here, and the list of functions that it has to consume for demoing purposes here. It's going to consume the 4,000 messages, all right? So let's do that. You can see that it's running, it's consuming all of the messages, it's printing as I expected. And if I go back to Redis Insight and I refresh the page now, you can see that we now have one consumer here, and that the last delivered ID, the last message that was delivered to this consumer group was this one that ends with 526, which I expect to be the last one, exactly 526 from the string. And, well, let's do the filtering part now. And to do the filtering part, what I want to do is use Spring AI. And I'm going to use two libraries from Spring AI. The first one is Redis Store, which is going to use Redis as a vector database, and the Spring AI Transformers, which is going to allow us to use embedding models from Hugging Face. So Hugging Face is this open source, it's like a GitHub for models, for machine learning models that you can find online, right? And you can see that the first thing I'm going to do is instantiate this object of a transformers embedding model using this embedding model from Hugging Face here. And then I'm going to call the Redis vector store builder and create an index inside of Redis, which is this classifier ID X, so that I can query the data, do vector similarity search, for example, later on from Redis. And what I want to do is I have this list of references, so basically filtering examples.json here, which I'm going to store in this variable references, and then I'm going to store all of them into Redis as JSON documents. And the Redis vector store object is going to actually turn them into vectors. So if I go back to Redis stream, to Redis Insight, you can see that all of these references were created inside of Redis. This one, for example, using LangChain with Weaviate for a hybrid search setup. Oh, this is a bad one, right? I'm talking about the competitor here. Let's try another. What is ChatGPT? So you can see that this is the reference, and this is the embedding, or the vector that was created for this reference. All right? And what I want to do now is basically create this classification function that is going to return. I forgot to. What happened? Remove URLs. Okay, let me take this off for now. Oh man, I don't know what happened. Okay. And I'm going to try it out with a few examples here. So the first example is Redis is a great tool for building applied AI systems because it's a vector database. So let's see the score. So basically it matched this sentence here that was stored in Redis, which is best AI tools right now, and the score was 0.8. If I try with that other sentence, that is, I'm here at Kotlin Conf, I can't stand people talking about AI anymore like I'm doing. People cannot stand it anymore, right? If I run that, you can see that I broke that into two different clauses, actually. So I'm testing each of the clauses of the sentence separately. And for the first one, which is I'm here at Kotlin Conf, I got a score of 0.68. This score could be from 0 to 1, all right? And the higher, the most similar it is. While the second one, which is actually I can't stand people talking about AI anymore, got a score of 0.8, right? And then I can keep testing, but testing this is not quite cool, but you can see Santos is the best city of Brazil, and it matched Cloud AI, which is not similar at all. And you can see that the similarity score was also low, 0.57, because it's not similar to the sentence. All right, so what I want to do is create a filtering handler now. And in this function, what I'm going to do is I'm going to call the classify function that is going to return the score, as you saw. And if the score is higher than 0.75, which I chose randomly, might not be very well tuned for this data set, it's going to mean that it's about artificial intelligence. And if it's about artificial intelligence, then I'm going to store that in Redis, in a Redis stream, and also as a hash. All right? So let's also create this function to store the event in Redis, and also this function to store the event in a stream. Let's create a new consumer group. And what I want to do now is I want to create two consumers at the same time using coroutines, so I can show you that I can have multiple consumers consuming from the same stream at the same time. The parameters are all the same, with the exception of the consumer here, which for the first one is store1, and for the second one is store2. But both of them receive the same list of functions where they're going to filter. And if it's about AI, then it's going to print the URI, it's going to store in Redis, and it's also going to ingest into the stream. So let's run that. But before we do so, there's a disclaimer. Well, let me just... OK, sorry. All the other conferences I went, I'm not very photogenic. You know, my photographs are always bad. But this one, I think, is going to be good. Anyway. Where was I shouldn't have done that. I shouldn't have done that. OK, so let's... I was going to say the disclaimer, because we're talking about real-time data and data that I have no control of. So you're going to be listening to Bluesky's JetStream. I don't know what's going to come up from there. All right, so maybe it doesn't work as expected. Let's cross our fingers, but that's the disclaimer. You see, we're consuming a lot of messages. We're filtering them. Let's wait for this to finish. OK, finished. And if you go back here and refresh that, you can see that this new stream was created, the filtered events stream, and also all the posts that were filtered were stored as hashes inside of Redis. Maybe it worked as I expected. Maybe it didn't. Let's cross our fingers. So let me open the filtered streams. So the first one is about AI. That's pretty cool. AI's medical diagnosis skills still need a checkup. The second one, the new shape of care by women dying. I don't think it's really about AI. Reminder, the weekly, this one is not also really... Yeah, you see, the thing, this one is about AI. So what I'm going to do is actually run the applications that are going to keep consuming messages behind the scenes for us and filtering these messages already, so you can have a large data set to play with later on. Okay, because that's the trade-off when you're doing classification with vector similarity search. Basically, you're not probably going to have the same accuracy that you would from an LLM, but there's a cool thing. You guys remember that I created the references using an LLM. So I didn't really look at the references that were created. Maybe they're not the best ones. And I only have 139 references here. Okay, so I'm trying to classify those on only 139 examples. And it's working fairly well here. And if I refresh that, you can see that I already have 31 messages. And if I refresh the stream, you can see that AI art inspiration and Java students AI. I do have a decent amount of FAQ and general info about projects. This one's not really, apparently. Work on my first conlang right now. Not sure, a lot of text. What does... OK, AI is Clippy, Cloud. You can see that most of them are about AI, but a few are actually not. And we're still consuming. And that's... Go to the next part of the presentation, which is challenge number 3, which is actually enriching the data, where you're going to do the topic extraction. All right? So for each of these messages, you want to extract topics from them. Why? Because you want to increase the granularity of what's being talked about, and also because you want to keep track of how popular these topics are for later processing, as you're going to see. Okay, and how are you going to do that? So basically, you're going to listen to that stream, which is the filtered stream. And then you're going to we're going to use the topic extractor service to extract the topics and insert these topics in their respective posts inside of Redis, right? We can, unfortunately, for this specific use case, I couldn't use a vector database because I didn't know the topics beforehand. So I have to use an LLM here. I have to go to the LLM and say, hey, what topics can be implied from this post? And then I can update the post in Redis and also increment the topic counters in the TopK, which is a probabilistic data structure that if I have time, I'm going to go into details by the end of the presentation. But it's used for estimating the frequency or the most frequent elements in a data stream. So let me stop the two applications, and let's go to the third notebook here. So I'm going to include these dependencies, which is basically Spring AI Ollama, so that I can run the model that I'm running locally in my machine. I'm going to have this prompt that is basically saying, hey, you got to get the, please, what topics can be implied from this post. I'm going to instantiate the Ollama chat model here, which is going to be based on the TipC Coder v2 that I'm already running locally on Ollama. I'm going to have the function for extracting the topics. They're going to return the topics for us, and you can test it. So Kotlin is a great programming language for beginners who want to build agentic AI apps. And if I run this one, every time you run Ollama for the first time, it takes a little bit to warm up, but the subsequent is always a little bit faster. Right? So you see that it took 6 seconds, and it returned these topics. But if I run that with something else that is not related to AI at all, I expect it to return nothing. So Brazilian samba is a great music genre for dancing, and it returned nothing, as I expected. So I'm going to create this function to create a TopK data structure. I'm going to create this function that is actually the handler that is going to do the TopK extraction, and it's going to add to the TopK, and it's also going to update the post, the hash of the post, but it's only going to update this single field. It's not going to overwrite the whole post. All right? And finally, I'm going to add all of the topics into a set inside of Redis. You're going to see all of that. I'm going to create a consumer group for that, and let's consume that stream, and let's see if it works. I'm going to do that for 100 messages. So you can see that some topics have already been identified here, 14 topics. AI conversations, generative AI, natural language processing, NLP, etc. We have 59 in total. And if I get one from here, let's see, because I only consumed 100. But we only have 59, so should be enough. If we open one at random here, I would expect the topics to have been inserted. So generative AI, AI art generation. So for this post. But what I wanted to keep in mind here is that we might have multiple applications consuming the same stream and updating the same post. In a regular use case, this would be a problem if you came across race conditions, right? But for this use case, it's not a problem because you're updating only one field instead of the hash. You're not overwriting the whole hash, basically. So this process is only going to update this field. If you have another process updating a different field, they're not crashing with each other. Okay, let's go back to the notebook, because what I want to do now is create a new index inside of Redis for actually searching through these posts. And let me go to the workbench, and what I'm going to do is I'm going to call ft-info, and you can see that we have 2 indices created inside of Redis already. And if I run this one, you can actually see the index. So basically it's for topics, the attribute of topics and text inside of these keys. And let's see if it worked. But if I change that for the post ID X index, you can see that all of these keys were indexed by this index. All right, all of them have topics. And if I go back to the notebook, what I can do now is, first of all, I can query the TopK to see what were the most mentioned topics. So you can see that prompt engineering was mentioned 16 times, generative AI was mentioned 12 times, conversations was mentioned 11 times. And what I can do now is I can try to fetch from Redis. I can do searching inside of Redis, right, using my index. So I can do that. So let's get prompt engineering as the tag. So basically, I want to search all the posts whose topics include prompt engineering. And if I run that, not all the posts, only the first 10, if I'm not mistaken. But you can see that those were the posts that were retrieved from Redis, and all of them have prompt engineering as part of their topics. Okay, and the next thing I want to do is full text search. So if I get one of them here, so AI art inspiration, for example, and I try to search for it, I expect it to return this one. So basically, this is full text search, just exact keyword matching, all right? And after that, we can also do vector similarity search if we create embeddings for this text. So this is how we tackle challenge number 3. Let's talk about challenge number 4 now, which is analyzing the data and taking action. So basically, what we have to do now is understand what functions to call. All right, so our bot, based on the message from the user, needs to understand, okay, what function should I call inside of the application? We're going to have 2 functions, the listing trending topics and the summarizing posts. All right? And the way we can identify these functions, we have 2 approaches to do so. The first one is using an LLM, and this is what Spring AI does, for example, or what LangChain does when you call the .tools function. I don't know if you've seen that at Urs Peter presentation yesterday, for example. I think Rod Johnson's presentation also did something similar. But basically, you're calling an LLM, and then you're asking, hey, these are the possible functions. What function should I call based on the post? And then you're going to get the answer from the LLM. You're going to invoke the function in your application, and then this function is going to return some data that you're going to stuff into the prompt, and you're going to ask the LLM again, okay, based on this data, how do I answer this question now? But what if we could call the LLM only once? This is called semantic routing, actually. And that's actually approach number 2, sorry, which is using a vector database like Redis and doing semantic routing. So in this case, we're going to do something very similar to the filtering part. We're going to come up with some references, which we're going to vectorize, insert into Redis, alongside the route itself, so which route it should call, and also a minimum threshold, as you're going to see later on. And after that, what we want to do is having your bot vectorizing the post as well, getting this vector going to the vector database, comparing to the references for routes that exist in there, get the most similar one, and if it's similar enough, you say, all right, this is the route that you should follow so that you can call the right function. So that's basically what we're doing here, so that after the function has returned the information, we can stuff it into the prompt and ask the LLM to come up with a final answer. So you see, we're not calling the LLM twice in this case, we're only calling it once to generate the final answer. So let's see how this can be done in the notebook. This is the 4th notebook here. Let's go to the beginning. Let's clean all the outputs. So let's include these dependencies. So this is the first route, the trending topic route, and these are the references for this route. All right? So what are the most mentioned topics, what's trending right now, what's hot in the network, and top topics. So what I expect is that if anybody asks my bot something similar to this, that it's going to be able to match these references in the database and point me to the right route. Okay, so let's create this. Let's instantiate an embedding model to turn those into vectors again. And what I'm going to do now is I'm going to create a new index inside of Redis using the Redis vector store, a new one. And this index is going to be the route ID X. And based on this index, I'm going to store all of these references into Redis with the actual route and the minimum threshold that it should meet in order to say, okay, this is similar enough, you should follow this route. Okay, so let's run this one. And now if I go to Redis, I should see, let's see all the keys. Let's refresh. You can see that now we have this key space, which is route, with the references created in here. So we have the text, what's trending right now, the vector representation, the route that it points to, and the minimum threshold, which is 0.9. And if we go back to the notebook, we can test it out already. So basically, we have this example, which is, hey, Dev Bubble, what's trending today? Excited to hear the news. And what I'm going to do is I'm going to perform similarity search using the Redis vector store, and I'm going to print out the score. Okay, so you can see that this one matched this text, what's trending right now, with a similarity score of 0.9, which is actually higher than the minimum threshold that I had put for this one, meaning that it would call this function. All right? Now I'm going to create a function that is more detailed for matching routes. And this one is actually going to break the post into different clauses as well, separate clauses, so that I can improve the accuracy. So if I run that again for this sentence now, you can see that it tried to match for each part of the sentence. So this part, the second part, and also the third part. For the first part, it got a similarity score of 0.79, meaning that it wouldn't call this route. But for the second one, it got 0.94, even higher than before, right? Meaning that we would then call the training topics route that is actually returned by this function. Now that we have this function, we can put all of that together. But before, we need to actually implement the actual training topics function that is going to be called. And this function is very simple. It's only going to query the top K and return what are the topics that are training right now. So those are the topics, as you saw before in the previous notebook. And then we're going to create a routes handler function that is basically going to get the route that was returned, the string actually that was returned from the match route function, and point it to the correct function to call inside of the application. Let's do that. And then I have this process request, which is going to receive the post from the user. It's going to receive the routes handler so that it knows what function to call. And what we're doing here is we're trying to match the routes. Then if no route is actually matched, I wanted to return a default response, which is going to be, sorry, I couldn't find any relevant information from your post. Try asking what's training or what people are saying about a specific topic. Because I don't even want to call the LLM if I cannot call any function, all right? I just want to return that directly to the user. And finally, if it actually returns something, I'm going to call the function that is actually routed from this route. I'm going to get the information from this function, which is the enriched data, and I'm going to stuff it into the prompt that I'm going to send to the LLM and expect it to generate the final answer for me. We're almost there. We're almost there. So let's test it out. So process user request. What's training Bluesky now? So you can see that it matched this text, what's trending right now, even though the string was actually different, with a score of 0.91. This is the enriched data, and this was the LLM response. So Bluesky has been buzzing with discussions around generative AI and its impact on various sectors, especially a market where it's reshaping how brands engage with clients. So generative, probably there's something about marketing here, I would expect. Yeah, we can always try that again. But now it's more about prompt engineering. I gotta prepare prompts that are better for my LLM to understand. But basically, you can see that this is using the topics that were provided to it to generate the answer. All right? And now let's talk about the other function, which is the summarization function. We're going to perform the same thing here. We have all these references for summarization. We're going to store all of them into Redis with a different minimum threshold. Then we're going to implement the summarization function, which is basically understanding what topics people are asking about. So, for example, they can ask, hey, what are people talking about in regarding of ChatGPT, for example, or OpenAI, or Claude, or something else. And what I want to do is I want to go to Redis, and I want to search for all the posts who contains these tasks, and then use that as the information that I provide to the LLM to answer the final user. All right, let's test it. So what's being said about prompt engineering? Let's see what it returns. So basically, this is the post that was used to enrich the final answer. OK. And now we can create the routes handler with more than one route here, and we can test it out. So what's being said about prompt engineering? So the same one was returned, and it came up with an answer based on this information. Or we can do what's training now, and expect it to match the training function, and it said the top key. Top key no, it doesn't exist. Why is that? Let's see, line 12. Top key. I think. It's because I create different top keys, actually. Let me run the top extraction app in the background, and let me run all the applications so that we get more information. Let's go back here. We're almost there. It's got to work. Let's do that again. OK, it worked. So these are the training topics right now. It's generating the LLM response. It did. So training topics. And finally, if I ask something that is not related to anything, you saw that it was super fast. And it just returned, sorry, I couldn't find any relevant information from your post. And that's basically it. So going back to the presentation, we can go back. We don't have a lot of time. So I'm going to explain that very easily, very quickly, actually, that users may ask the same question to your LLM, right? Multiple users can ask, what's trending right now? Or what are people talking about this certain topic? And we don't want to go to the LLM every time it happens because it costs money and it takes time, right? So what we want to do instead is cache these responses inside of Redis. But if we did like in a traditional cache, we would have to do the exact word matching to be able to come across something that had been answered before. So what I want to do in this case is use vector similarity search, semantic search, to try to match things that people have said in the past so that we can avoid going to the LLM and come up with the same answer back to the user. Right? And this is called semantic cache. Users may ask the same questions. And OK, let's look at the demo. So let me stop the applications. And this is the semantic caching one. And basically, I'm going to create an embedding model. I'm going to create a new index that's going to be the semantic caching index. And then I'm going to create the function insert into caching. Into cache, sorry, that's going to receive the post that's going to be vectorized and the answer. And then I'm going to create the function to get from the cache. And finally, I can insert something to the cache such as what's trending right now. And the answer can be this, this, and that. And if I try to get it from the cache later on, it's going to return this, this, and that. So instead of going to the LLM, I can just pick it up from Redis. Not using the same question. You see, this one was what's trending right now, and this one was what's trending today. Similar sentences, but with very similar meaning. And finally, if I try to get something that hasn't been cached, it's not going to return anything, and then our application will understand that it has to go to the LLM. OK, time to put all of that together because we only have 4 minutes. So what I'm going to do now is I'm going to run all of that, because Bluesky also offers a great and rich REST API that you can play with. Oh, it wasn't this one, actually. It was this one. I'm not going to show you all the code of calling these APIs, because you know how to call APIs, right? What I'm going to do is I'm going to test it out. So let me clean all of the previous responses here. And let's go to Bluesky. First of all, let me clean up the cache. Let me delete this from the semantic cache. And let's go to Bluesky. Where was it? Here. And let's ask something. So hey, dev bubble, what is trending right now? Let's post it, processing, and then what I'm going to do is I have this function, basically, that is going to search for posts that mention this handle, and then I'm going to do everything that I showed you before and post it back to the user. Let's see if it works. Oh, it's not finding. Did it work? Profile, let me refresh. Let's try again. Add dev bubble. What's training right now? OK. Now if I come here. Oh, no. No, it's searching for this handle. It should just match it. No, it's not about the OK, it's eventual consistency from Bluesky. That's it. OK, it matched my question, which was what's trending right now, with a similarity score of 0.99. And then the TopK does, oh, come on, let's try the other one. What are what is being said about prompt engineering. See, that's what happens when you start changing things like 15 minutes before the presentation. Oh, I forgot the handle. Yeah, sorry. I'm getting nervous. Dev bubble. What's training right now? And let's post it. I have 1 minute. Eventual consistency. And I should have deleted the previous one because I haven't optimized it for that. Let me delete you. Let's try again. Eventual consistency, of course. Oh no, what is being said about prompt engineering? So it's going to run the summarization. Let's see. Oh, I changed a lot of things. Oh, damn it. Yeah, but basically what we would see, I had some examples here before, was the bot actually replying. For example, I was asking about OpenAI, and it was going to reply, OpenAI continues to innovate with the release, like based on the information that it had consumed from the stream. Unfortunately, we have the demo and the troubleshooting demo. I only have 10 seconds, so I won't be able to troubleshoot that. But I hope you have got the idea and the message. I don't have time to talk about the duplication with probabilistic data structures, but you can talk about that later on if you want to. And finally, let me finish that by recapping everything you saw, which was basically how to use Redis streams for consuming real-time data, how to use semantic classification for filtering data, how to use LLMs to extract data, how to use semantic routing for calling functions, how to use semantic caching for saving money and time, and the last one we didn't